Hello, Browners. It's Isaac Brown here. This is my Halloween special, which is doing my AP Physics homework. Yeah, real scary, I know. Cause doing AP Physics work is just as good as being spooked out or watching scary videos or whatever people do these days. Anyways, let's try doing this. Okay.
Newton's first law says that an object will maintain.
What channel is this? They give us the option to use the app. Okay, forces, AP Physics, AP Super Cram Review. Okay, I remember that. AP Physics, AP on Physics. No, like forces. AP Cram. Okay, here we go.
Newton's first law says that an object will maintain constant velocity unless there's an unbalance on that object. People get this wrong all the time. They think that.
Okay, I'm gonna write down notes. As I do this, I take a picture of these and then send them to my teacher. Okay, what I have to write down here is Newton's first laws, or Newton's laws. So let's see here. Okay, I'm writing down Newton's laws. You'll see the picture later. I'm putting the first law as objects maintain constant velocity unless there is a force.
To maintain constant velocity, you need a force.
Okay,
it's the opposite. If a box of mass m is moving with constant velocity, it wants to keep that constant velocity, and the only reason that it would not keep that constant velocity is that there's an unbalanced force on that mass, like a frictional force causing the box to stop.
Okay.
The property of objects wanting to maintain constant velocity is called...
Let's write that word down. I'm writing down somewhere on here. Inertia. Property of objects that makes them. Let me make sure the screen don't go off. To make sure, it makes them want to maintain constant velocity. Carry on.
Called inertia. If there was no force on an object, what could we say about the velocity of that object? Could we say that the velocity is zero? No, we could not say the velocity is zero. Forces only tell us information about the acceleration of that object. Newton's second law is an equation relating the sum of the forces on an object and the acceleration of that object.
Okay,
the larger the mass an object has, the larger inertia it has, which means it wants to maintain its constant velocity more, so the acceleration is going to be less. Just like 2D kinematics, you have to treat the horizontal and vertical components of the forces separately. Plug only x-directed components into the x equation and only y-directed components into the y equation. If done properly, these equations will allow you to solve for the horizontal acceleration and the vertical acceleration. Don't mix up x-directed forces with y-directed forces in a single equation. Newton's third law says that two objects will always exert an equal and opposite force on each other. Even if the mass is small and the mass of the other is great, the forces on each will be the same. Since the forces are the same, will the acceleration of these objects be the same? No, the acceleration will not be the same because the mass of these objects are different. which means the larger mass will experience less acceleration. Here are the most common forces you're going to deal with. The force of gravity is just mg, that's why everyone loves it, but that's only true near the surface of the Earth. If you're far from the surface of the Earth, or if you're on another planet, you have to use the more general equation for the force of gravity. The normal force exerted by a surface is also usually just mg, but don't love it so much because sometimes it's not mg. If you're on an incline, the normal force is going to be mg cosine theta. An object being pushed down on or pulled up on is also not going to have a normal force equal to mg. It'll be large, smaller by the amount you push down or up on the object. In an elevator, the normal force is going to be mass times the gravity plus the acceleration or minus the acceleration of the elevator, depending on whether it's going up or down, respectively. It's important to note that scales that you stand on measure the normal force, not your weight. The force of static friction is what causes objects to not slip on a surface. People often think that the static friction is equal to mu times the normal force, but it's not. That's the maximum value of the static frictional force. Static friction will only match the force trying to make the object move. If I push with 10 newtons, static friction will push back with 10 newtons. If I push with 20 newtons, it'll push back with 20 newtons. It'll continue doing this until I reach the maximum static frictional force, which is just mus times the normal force. Kinetic frictional forces don't care how you push on the object. If the object is slipping, then the value of the kinetic friction is always going to be mu k times Fn. The spring will exert a force if you its equilibrium position. K is the spring constant. X is not the length of the spring. X is the amount you displace that spring from its natural equilibrium position. Objects placed in a fluid will experience an upwards buoyant force equal to the weight of the fluid they displace, called Archimedes Principle. V does not necessarily refer to the volume of the object. It refers to the volume of the object that's submerged in the fluid. Rho is also not the density of the object, it's the density of the fluid. The density of the fluid times the volume of the object submerged in the fluid gives you the mass of the fluid displaced times g gives you the weight of the fluid displaced. That's why this equation is just another way to state Archimedes' principle. The formula for the electric force looks just like the formula for the gravitational force. Just replace the gravitational constant with the electric constant and replace the masses with charges. Even though mg is everyone's favorite force because it's so simple, people always forget to use QE to find the electric force. But just like you never use the big ugly equation to find force of gravity, if you could just use mg, you should never try to use the big ugly equation for the electric force. If you already knew the electric field, you should just use QE. There's two formulas for the magnetic force because one's for the magnetic force on and one's for the magnetic force on a wire. Notice that there is no formula for tension. The only for tension is by plugging it into the left-hand side of the sum of the forces equals ma and then solving for t. Just make sure if the tension is directed at a weird angle, you only plug in the x components into the x equation, like t sine theta or cosine theta, and only plug in the y-directed components of tension into the y equation.
Okay, I'm going to write down number 1 and number 2 of this one. Okay, let's see here. Solving 2D force vector problems. I don't know what to write down for the other slide that I saw on here, but whatever. Okay, number 1. Draw. Remember, I don't want the screensaver to kick in on here, so I'm gonna keep tapping the screen. I can make that O back then on the. I made the C a O on forces. Oh well, I fixed it. Okay, exerted on the object you are concerned with. Okay, and then number 2, break each force into vertical and horizontal components Fy and Fx. Okay, let's see what else you gotta say.
Like t cosine theta or t sine theta. All of these forces that we've talked about would go into the left-hand side of sum of the forces equals ma. Many people fool themselves into thinking that ma is a force, and they try to plug ma into the left-hand side of sum of the forces equals ma. But ma is not a force, it's mass times acceleration, and it's required to be on the right-hand side, and the only thing on the right-hand side of sum of the forces equals ma. Inclines are kind of weird. For 1, the normal force is not equal to mg, it's equal to mg cosine theta. For 2, you don't break up vectors into x and y components, you break them up into components directed parallel to the incline and perpendicular to the incline.
That moment when
the component of gravity parallel to the incline is mg sine theta. What do you do if you have 2 different masses required to move the same way? Treat the 2 masses as one big system, then only look at external forces that try to make that system go and try to make that system stop. External.
Like, I am good with these. I know I talk about it after this video ends.
Forces that try to make it go will be positive, and external forces that try to make it stop will be negative. Those go on the left-hand side of sum of the forces equals ma. Just make sure the m and ma is the total mass. This will let you solve for the acceleration using only one equation.
Okay. I'm gonna take a picture of my notes. Okay, no. Okay, basically, here's what I think. Like, I'm a relatively good student in school. Like, I'm a full-time AP student. My strength is like reading, science, minus my weakness. And any other class, I could pretty much do it. I can even do art better than my weakness. And my weakness in school is literally math. Like, I don't know why I took the high honors elementary functions class, which is killing me right now, and this AP physics, which is heavily math based. Like, this stuff is really this stuff is like a threat to students, because like, they don't do well, because some students are not too bright, but they want to, like, some students are not too bright, but they want to try some new things to see if they could advance themselves. But if they do that, they had to risk putting their GPA under risk. So like, I don't know, guys, but like, I feel like even if you're a full-time AP student, I just feel like that they should like have some leniency with the GPA type of stuff, because they just take away that risk. More students will be less stressed out and stuff like that. But anyway, why am I making a PA video out of this? Okay, I'm gonna take a picture of notes and I'll show you guys me sending it to them. Let's pause this real quick. Okay, I'm gonna show you guys how to send this to your stuff. Okay, so click on Edmodo. That will happen. Now hold on. Okay, hold up, guys. Okay, now I finally can turn this in. Oh, good, I can skip that part of the video. Good idea. Now what you want to do is attach. Click on attach. Then you can say choose from gallery. Then go to gallery. And then that's how you do it. Should I say something? Okay, do not post in the comments. Oh yeah, I'm not sure if you mean like the response of the comments, but whatever. Here's all the notes I can gather from this. Wait for it to load. Bada bing, bada boom, I did. Alright. Anyway, see y'all around. Happy Halloween and all that. This is like the scariest thing. This is pretty much like a Halloween special. Matter of fact, I'm gonna title this my Halloween special.